All right, so back with the Honeypot project. In today's crash course, we're going to be developing honeypy, written in Python. Based off of this threat information, we can catch hackers in terms of what commands they're supplying, the IP addresses they're coming from, and what kind of login information they're using. If you are somebody who is looking for a security project in Python, I would recommend checking out this crash course. So let's get over to the overview video. All right, so welcome to the honeypy crash course overview. In this crash course, we are going to be creating the honeypy project, breaking this down into different modules and iteratively making this a full-on, fully fledged honeypot. So a quick overview of what we're going to be doing in this crash course. So right now we are in the honeypot overview. I'm going to be overviewing or showcasing my dev environment, and then we're just going to quickly break down what we're going to be doing in the honeypy project. Like I said, it's going to be very modular. So each of those bullet points or sub bullet points is going to be a Python file, and it's going to fulfill a certain purpose. So like creating the SSH honeypot or the HTTP based honeypot, and also creating those dashboards. And then finally, we're going to be deploying honeypy out on a VPS using Hostinger. First off, what is a honeypot? For those of you who don't know, a honeypot is a decoy host or server emulating or impersonating some sort of business infrastructure. This could be a host, a workstation, a server, a database, or even a file, also known as canary tokens. There are many different types of honeypots out there. There are corporate or actual commercial-based honeypot providers, and there are open source providers out there that you can go out and download and tinker around. Now, honeypot is a part of what they call deception engineering. It's a certain domain in security where you're trying to lure hackers, attackers, and overall collect threat intelligence information based off of how they are interacting with that environment, perhaps how they got into it, what kind of commands they're supplying. And this is part of what they call deception engineering. So there are two types of honeypots. There is the honeypot in general. So this is just going to be a singular decoy system designed to attract or trap those cyber attackers. And this perhaps may look like just a server, maybe a compromised server, some database files, or anything really you can think of that would be maybe interesting to an attacker's perspective. Next is expanding upon honeypot, which is honey nets. Honey nets are basically a whole bunch of honeypots put together, and it provides more of a simulated network environment, emulating perhaps different levels or systems within a network. So there could be an Active Directory server, there could be a database server, and maybe a few workstations that are all connected. And it maybe perhaps looks like, this is a legitimate branch office, for example. And what you're trying to do is collect extensive information with how the attacker was able to get into the environment, how they're able to move laterally, escalate those privileges, and overall compromise, quote unquote, the environment. Now, for the honeypy project, we are going to be creating this using Python, as the name denotes, Py. Right now, I have Python 3.11 installed on my Windows 10 workstation. Python is platform independent, so it doesn't matter whether you're on Windows, Linux, or Mac OS. You just are going to have to configure your environment for whatever of those OSs you're using. Now, as my IDE or interactive development environment, I'm going to be using Visual Studio Code. It's a very popular IDE, and it's just something that I prefer. It's relatively easy. I'm not going to go overview like how to install any of these today. I'll put some tutorials down in a link in the description below, or perhaps some blogs that can walk you through that. So a quick project breakdown. honeypy is going to be modular. So we are going to break out the different functionalities into various Python files. And you may be wondering, why do this? Well, like I said, it's a modularity thing. So if, for example, you wanted to add a email server capability, or perhaps Telnet, or some other capability, you can do that. It's not basically monolithic in terms of the application stack. It is you're able to add in different Python files, add in different HTML templates, whatever you want to do. And that's the idea or design I had when I was initially developing honeypy. So in honeypy, we're going to start out with creating a basic SSH-based honeypot. We're going to be provisioning or creating an emulated shell environment, handling that client connection with Perimiko library and sockets library, and then we're going to deploy that honeypot out on your local host so you can kind of see what kind of log files or information that you can collect from those log files. Next, I'm going to be adding the argument parser. So honeypy is a command line centric tool, meaning that to provision a new instance of honeypy, you can go into your command line and you can supply the arguments. For example, perhaps it's -SSH or HTTP. You can supply a username and password that you want to accept that will authorize the user into that emulated shell environment, whatever that is. And so to provision a new instance, it's easier just to use argparse. It's very simple to the argparse library is going to help you kind of create an environment that's similar to what you would see with Linux, for example, when you do ls-l or any of the other options that you can use. Then we're going to expand on our honeypot offering the HTTP-based honeypot using Python Flask, serving a very basic HTML file. Now, in this video, I'm not going to be showcasing how to create that HTML file. You're going to just download it from the GitHub repository. That's the honeypy repository. And it's not worth the time in this video. I'm just going to try to save some time on that end. Now, we are going to be using several third-party libraries. As you can see at the bottom, we have some standard ones that come pre-packaged with Python when you install it on your operating system. So that's threading, time, and OS. You don't need to worry about those. As you can see here, we are going to be importing specific libraries for various functionalities. For example, Dash is going to help us with those dashboards. Pandas is for tables or data frames. Flask is for the web server. Perimiko, SSH, and much more. So as we go throughout this environment, right now my development environment already has these libraries installed, but I'm going to show you or make sure that I'm highlighting when you need to install those libraries so that we can be in a similar environment. And then finally, we're going to deploy this out on a virtual private server. So my recommendation is that you use some sort of VPS service out there. Usually we charge less than $5 a month for a certain amount of bandwidth, and it's just because these are just going to be log files, it's not going to be that much. So I am using the Hostinger VPS. You can use the code here to get 10% off Hostinger. It's not sponsored. Hostinger did not sponsor this crash course video, but they did give me this code that you can go out and use for 10% off. And I'm going to be using a common Linux distribution. As you can see by that logo, perhaps that is the Ubuntu logo. I would recommend just sticking with Ubuntu or Debian or a Debian-based Linux distribution. And what we're going to be doing is just deploying this out there, and then you can collect those log files. Now, if you need any help or perhaps you're a bit confused, you can reference the README file as well as just the GitHub project, SSH honeypy project on GitHub. You can look at the Python files, you can look at the HTML files, and that README, it's going to walk you through how to actually run or provision an instance of honeypy. And it's just a decent way to look if you get lost, or perhaps maybe I've missed something small on my side as I record this video. And maybe one more thing is you'll probably see lots of iterations of me with messy hair or different shirts as I record this over the next probably week. I'm trying to do this quickly, but at the same time, I want to make sure that I do a good job. And so yeah, you're probably going to see lots of different iterations of me as I go throughout my day. So with that being said, let's hop into our development environment. I'm just going to quickly overview what I have on my Windows 10 host, and then we'll get up and running with developing that SSH-based honeypot. Okay, so transitioning over to my VS Code view here, as you can see, I have a blank Python project started up on VS Code. A few things to note here. First off, you will see that I am using this Grant desktop here, and this is actually Ubuntu 22.04 WSL, Windows Subsystem for Linux. So if we actually go down to my taskbar, you're going to see I actually have WSL installed on my Windows 10 environment. You can go to the Windows Store and download Ubuntu 22.04 if you want to develop in a Linux environment. Now you can do this with Windows. Now, I have opened up a new VS Code project here just to showcase how you would run your Python scripts using the standard terminal application on Windows. And that is simply using Python followed by the Python file name with a backslash. So SSH honeypy, you're going to see hello world. Now, if you want to go out and actually have a WSL in your VS Code, I'll leave again a link in the description below. For the sake of time brevity, I'm not going to overview how to do that. Going up into my project folder here, I've created a baseline folder called cc honeypot, and then I have an ssh_honeypot.py file. You're also going to see this .venv. .venv stands for virtual environment. Python virtual environments allow you to isolate your code. We're basically layering on top of the baseline Python environment. The most common use case for a virtual environment is to separate the Python libraries or modules that you use. So I already have downloaded all of my Python libraries on my desktop local installation of Python. But for the sake of this crash course, I want to show you or showcase what I'm doing throughout this project that includes downloading those libraries. So you are welcome to provision a virtual environment, but it is not necessary or required. You can just download the libraries or modules on your baseline Python installation. So that is a basic overview of my environments that I have set up for this development. Let's go ahead and get started with that SSH honeypot. Okay, so let's get up and running with the SSH honeypot. We're going to be using SSH as our main interface to lure attackers into our host environment. What we need to do in Python is create logic which will allow us to log the username, password, IP address, emulate a small shell, and actually handle the client connections and handle the SSH handshake. So we have a lot to do here, and as you can see up in front of me, I have a little bit of comments outlining the logic that I'm going to have when incorporating or writing this honeypot. Now, you're going to see my eyes be glancing over at my other monitor, and that is because I am referencing my other code that I actually created during the time. And so I am going to be using that as a reference because I don't feel like doing this from scratch in my head. And so let's go ahead and get up and running by importing the logging module. So the first part is the logger. We need to log the IP address, username, and password into a file. There is a logging library as part of the standard Python package. So let's go ahead and import logging and start out from there. Now you're going to see this down below, and I tried installing the logging library, but I realized that it's part of the standard Python library, so you don't need to worry about installing the logging library. Now let's go ahead and clear this so I can get this out of the way. Okay, so in the logger library, we have a few things that we need to do. The first thing is we need to create the or name our logger. We're going to be using the getLogger method as part of the logging library. So let's go ahead and do funnel logger equals logging.getLogger funnel logger. So we're going to call this the funnel logger. This is going to capture those username, passwords, IP addresses. Next is setting the level. So there's different levels of logs that the logging module will provide for us. If you take a look on the internet, you can see here are some of the ones: debug, info, warning, error, and critical. We're going to be using the info because this just provides general information on what's going on. So let's go ahead and add in our logging level using the set level method. So funnel logger equals, or set level rather, logging.info, which will provide the info logger. Next thing we need to do is actually set the handler. So what this is going to do is basically set where we're going to log to. And this requires another import from the logging library module, which is import from logging.handlers import rotating file handler. So now we can basically set the file that we're going to log to. In this particular case, it's going to be called audits.log. So let's proceed to set up this funnel logger handler. So funnel logger, and then we're going to be our file. So setting the logger, we're going to call this funnel handler. This is going to be the settings that we're going to give for our funnel logger. So we'll do rotating file handler using tab completion. And then this is where we can provide our file name. So I'm going to be using right now just a string called audits.log. And then in addition, we can add a few other options, specifically max bytes equals 2000. And backup count equals 5. So this is what we'll do here. Next, we'll add our format. So if we go to the top here, I'm going to add this to our constants and call this logging format. So how do we want our messages to be formatted in the log file? And I'm going to be using the .formatter method followed by the what we want, how we want to it, how, I guess, do that, I guess, yeah. Now we can set the format to our funnel handler. So if we do funnel handler.set formatter method, followed by that logging format, that's going to give us the format that we want. And finally, we're going to add all of this to our funnel logger object that we created here. So the funnel handler provides options. So it sets the format, it sets where we're going to log, and then we basically take those settings and put it back into funnel logger. So to do that, you just do funnel logger equal or .add handler funnel handler. So we're giving these options, these two options here to our funnel logger variable or object. So, or instance, I guess. So with that being said, what we can do here is just see if a audits log is generated. So I went ahead and ran our program, and as you can see, an audits.log file is shown cased here. Now there's going to be nothing because we're not logging anything yet, but we have successfully provisioned our audits log. Now we have to do the same thing because what I want to do is have an audits log to capture IP address, username, passwords, and then I need another one to capture the emulated shell, what commands the bots or whatever hackers are using during the Honeypot session. And I want to separate this because then we can go out and actually visualize this using Python, Dash, and Potly. So let's go ahead and copy all of this here. And we're going to paste it here, the good old copy paste. Okay, so we're going to change these variable names here. So if you select this funnel logger here and then you hit Control, I think, nope, never mind. You can't do that. Don't do that. Oh, shoot. Okay. All right. So we're going to just go ahead and change all of these. Actually, I know what it is. It's shift. Shift. Nope, never mind. Okay. So change all of these over to creds logger. And we're going to call this creds handler. And where we see the audits.log, we're going to rename this to cmd audits.log. All right, so now we have two loggers. And if we do Control S for saving and print, now we have two log files, cmd and audits logs. Good stuff. So with that being said, we actually have the loggers finished. We will add statements when we need to actually log something. Okay, so now that we have the logging libraries finished, it's time to do a little bit more of the fun part, which is creating the emulated shell as well as setting up that SSH server with Perimiko. So starting out with the emulated shell. If we go ahead and take a look into what we're going to be doing, we're going to be creating functions to make this more modular, and then we can call upon those functions when we need to use them. So starting out with the emulated shell, creating a new function, we're going to call this the emulated_shell function. Now this function is going to take two parameters. It's going to take channel and the client IP, and you'll see why we're getting both of these in a few moments. Now the channel is basically going to be our way of communicating or sending dialogue messages or strings over the SSH connection. So what we're going to be doing first off is just doing a channel.send followed by our little prompt. So we can make this whatever you want to, and what I mean by prompt here is every single time you hit enter, you're getting this same prompt here, and so I'm going to be making it the name of corporate jumpbox $2 if I can find the $. So the $sign denotes that we just have standard user permissions. We're not in an elevated shell environment. And so when we do channel.send, what will happen is it's going to send out this default prompt. Now, this is probably a good time to go ahead and import the sockets library. So you can just do the import socket and we're good there. We will be using this soon. And if we go back down to our emulated shell, the next thing we need to do is provide our opportunity to receive commands. So, every single time that we send this, we also need to be listening to receive those commands. So we're going to be listening to a new variable called command, followed by binary, and then the little double quotation marks here. And so basically what we're trying to do is create a loop, which is going to loop through the shell environment, or basically create a small shell environment. And whenever the user enters exit, as you would in a regular shell or terminal session, you will exit the terminal and you will close the connection. And so what we're going to do is create a while loop, while true. So the first thing I need to do is listen to the channel. So if we do channel.receive1, what we're doing is basically listening to user input, and we're going to send that in the char. The next thing is if we don't get a character variable inputted in, we're going to close the channel. So remember that this variable is basically listening for user input. And what we want to do is append each of the characters that's inputted into the shell as a command. And when hit enter, it basically it puts together all of those characters into one string. And then based off of that string, you can evaluate logic. So what I'm going to do here is create a new variable again called command plus equals to char. So we're going to basically make all of those character variables into one singular string. Now we're going to actually evaluate our logic. And what I mean by this is where we can actually have a little bit of fun and enter in the various commands and basically create a small little emulated shell environment. So if we're going to do if char is equal to the binary of R, we're going to be doing the following. And this is where we can list out our commands. So let's start out with our exit command. So if we do command.strip equals b exit, response equals, I know I'm going a little bit fast here, but on new line, goodbye, new line, channel.close. So like I said, when we enter in the exit, it's going to close the channel. Next, we can add in various other commands. So let's do if command.strip, and what we're doing with the .strip method is basically making sure that we're getting just the raw input. We're not getting no formatting. And let's go ahead and do a print working directory, for example, pwd. And here we can type in our responses. So we can do response equals whatever we want it to be. So when we do a print working directory, I'm going to be using new line followed by user local oops, plus B R N. Now we're adding a few escape characters. So as you can see here, we have the user local with some escape characters, a new line, as well as this \R, which stands for the character return. And so the reason why we're listening to this is whenever you type in a command, you hit enter. And so once you hit enter, it's going to evaluate one of these commands. So if we proceed forward here, as you can see, one thing I did forget is the elif here, and let's proceed to just kind of test this out to see what's happening. So we can do a channel.send response, and then do a channel.send the corporate jump box. So we'll proceed to do this here. And then we will reset the command to this. So this will handle our session basically once we go through our little switch statement or if statements here. It's going to repopulate the default dialog box as well as listen for our next command. And what we can do is continue to add on to our command support. Now I'm going to just kind of quickly go through this on with our command support here. So let's proceed to the next one, which is going to be our who am I command. So if we do binary of who am I, we can type out our response here. And I'm going to use corp user1 as my username. And I forgot to actually do an equal statement there. So I'm actually going to just copy this in to save a little bit of time here. But basically, again, what I'm doing is creating a new line and then supplying the username password or the who am I, and then, yeah. Okay, so next is the ls command. What I've done here is added our little spoofable file of jumpbox1.conf, simulating a jumpbox environment, kind of going in with the theme of creating a jumpbox. The next thing is going to be the cat command. So we'll do elif command.strp equals b cat jumpbox1.conf. So let's say the attacker wants to see what the contents of this configuration file are. What are we going to do? Let's just do a copy and paste of that response variable and supply a different string. In this case, it's going to be go to debu.com for your own merchandise. And then finally, let's do an else statement. So if none of these commands are used, and you can continue to add more commands, feel free to add whichever ones. We're just going to stick with these for the time being. So what we're going to do now is do an else, and basically how we're going to do this is if the attacker puts in anything else like hi or hello, whatever, it's just going to echo that back to them. So let's just go ahead and do a response equals binary, new line, and we're going to follow that by a bytes object of command.strp. So basically, we're just parsing whatever they input, whether that's hi, hello, fine, whatever that may be. And that will proceed to basically just input that back out to the screen. So with this all done here, I noticed I did a little bit of a little different here. So I'm actually going to correct what I've done, which is, as you can see, we have this little binary thing that I don't know what I'm doing. Let's see, user local. I'm gonna delete it. Okay. All right, so our emulated shell is finished for the time being. There is a few other outstanding items we will need to add in terms of the logging. But before we can do that, and before we can actually go out and basically create this log. All right, so now let's go into the next part, which is going to be handling or setting up the SSH server. So Perimiko is what I've used as my library for handling the SSH v2 protocol. Here we can have both a client and server configuration. We are going to be using the server configuration. Now, a lot of this is boilerplate, meaning I copied this from the web where I found it, used ChatGPT to refine it, and so I'm going to be typing this up here. I don't necessarily know what all of this does, but you can kind of make sense of the logic. So what we're going to do before then is I'm going to import the Perimiko library. So if we do import Perimiko, we're good there. And for those who don't have Perimiko installed, it's going to be pip install Perimiko. Now I've already satisfied that environment variable there. So let's proceed on to creating our SSH server. So we're going to start out with the class, the default class called server. And this is going to set up that SSH connection. And we're going to be using Perimiko server interface as the method. Now inside this class, we're going to define several functions, and this is going to provide the setting for the SSH server. So we're going to first start out with a few outstanding items, including init. So if we do a define underscore init, have self and the class nature, client IP, input username equals none, input password equals none. And we are going to do self.client underscore IP equals client IP input Okay, so what we've done here is create some local variables in the class, and we've set the default values to none just in case. Oh yes, I see if I've made another mistake here, as with anything in programming. So these are going to be our local variables that are going to be interacted with within our server class. The next function that we're going to use is the channel type. So we're going to check channel, it's going to be check channel request. And it actually just already did that for me, but yeah, that's fine. So if you use VS Code, it's going to do that for you, but we're actually going to delete this here, and we're going to do if kind equals session, return perimiko.open succeeded. So we're basically sending a message if it's a session type, so the channel type is session, then it's going to say, okay, yeah, we can open the connection up and it'll be up and running. The next thing is going to be our authentication. So what are we wanting to use? So do get allowed auths. I don't like this auto completion kind of. It's a little bit interesting here, but get allowed auths, self, and the user, just the self actually, return password. Okay, so with SSH, you can use basic authentication, which is username, password. You can use public private key cryptography. We are just going to be supporting the password or a basic auth for this honeypot, so we can collect those credentials. Next is the check auth password. So here we can actually specify what our password is going to be. What are we going to accept for this SSH server? And for the time being, I'm just going to add a default statement. So we're going to do if self.username, let's see, equals username and self dot, let's see, actually it's going to be so I'm going to be using just default username password for now. We can add in an option later with argparse to specify an explicit username password given by the user. So for the time being, I'm going to say basically if self.input username is not none and self.input password is not none, we're going to do the following. So you can say if username equals So this statement here basically says if username is username, if password is password, then return auth successful, you're logged into the shell environment. We're going to do a few other handles here. I'm going to say else return perimiko dot auth failed. And that's, let's see, else return perimiko. Actually, that's fine. All right. Next function we will define is the check channel shell request. Self and channel dot set, and we're going to return true. So this is just checking. I don't actually know what this is doing. I think this is basically checking to make sure that you have a request. Next thing is the check channel pty request self, and then I'm going to copy all of this here. Oh gosh, this is a lot of code, but basically, let's make sure I got this right. So apologies for doing the good old copy paste, but basically here we are adding a whole other modes. So if you want to make the width and height and pixel height modes, you can check that out on the perimiko documentation. I'm just using that as a default. And then finally we have the define check channel exec request self, let's see, exec request self channel command equals stir command return true. Okay, so I know, apologies, I'm not expanding on what I'm doing here. So basically the check channel exec request is where we're actually going to handle the commands that are being input, and this is the good default for perimiko. So we have an emulated shell, we have the server environment being set up. Okay, so we have our basic environment set up here where we have the logger, we have the emulated shell, and we have perimiko server class in its following settings defined within these associated functions. Now what we're going to be doing is actually creating an instance of the Parimiko SSH server, and using the sockets library, we can allow the server to bind to a specific address and port, and this will allow clients to come and connect into our server. So we're going to be defining two additional functions for the SSH honeypy. The first function is going to be a client handle, and the second is actually going to take all of what we're seeing here and handle the rest of the client connection. You'll see about that after we define it. So let's proceed to start out with the client handle, and I'm going to be using a few constructs here from the Parimiko library, which will allow us to set up the SSH connection. So first off, let's go ahead and start with the definition of client handle. Okay, so we're going to start out with the parameters here with client, address, username, password. Okay, so what we're basically going to do here is set up a means of actually maintaining or creating a connection and then maintaining that connection. So first off, let's proceed to write out our logic for this function. We're actually going to have a try, pass, accept, pass, and finally pass. So what this block will do is allow us to go into this statement. It's going to try to do some sort of function. If it doesn't do that, then we're going to do a graceful error exception, and we'll exit out of the program. And then finally, we will do something else. Specifically, we're going to be closing that client connection. So the first thing that I need to do is get the client IP address. Where is this client coming from? And we can do that by writing client IP, and we'll get the IP address at index 0. And you'll see this, but basically we're going to be passing in a sockets method or construct that will gather that IP address for us. So we're passing in the client IP address we get. So as our server is listening on an IP address, it will connect, a client will connect, and it will send its associated IP address. And this is where we can gather that IP address. And we're actually going to do a little statement here with the printf function for formatting. We're going to say, hey, let's just say client IP has connected to the server. So the individual or script that's running this Python file will see a new client has connected, and then we'll output it to the console here. Now within our try, except, finally block, we're going to be adding some various logic. Okay, so we're going to delete the pass argument for the time being, and we're not going to keep that anyway. What we're going to first do is initialize a new transport object. What this is doing in the Parimiko library is handling the low-level SSH session. So let's define the transport variable, and we're going to do parimiko.transport. So this is initializing a new transport object and storing it in the transport variable. Next thing we're going to do is set the SSH banner version for this transport object. So transport.local version equals SSH banner. Now, the SSH banner is going to be a custom banner that I use ChatGPT to generate, and this will be a constant. We'll come back to this here in a moment. I want to finish constructing the transport object here. So now that we basically are handling a new SSH connection, what we're going to do, or a session rather, what we're going to do is go ahead and create or initialize a server. So, we've created the server class, we've defined the settings for the server. Now let's create an instance of that server. So what we're going to do is do server equals server client IP equals client IP, username equals, or input username rather, equals username and input password equals password. Okay, so in the server Paramiko class here, you can see that we have to define at least 3 parameters. Right now, these 2 are set to the default of none. We have to also pass a client IP. Now, if you can see in this settings, we have the username password, and we also have to assign a client IP address in order for the session to open successfully. So what we're going to do is what we did rather is we set a new server object. No, that's fine. So now with the transport variable, which is handling that SSH session, what I need to do is pass in that SSH session into the server class. So what we can do is do a transport that add server key. We're going to add a host key. We'll get back to that in a moment. And then we are going to do a transport dot start underscore server equals server. Okay, so what we're doing here is basically taking that SSH session and we're starting a server, an SSH server. And this line here allows us to supply a host key. So a host key is a public-private key pair which allows incoming connections or clients to verify that the server is who they say they are. And we're going to generate our own public-private key pair using SSH keygen. But let's proceed to first get this constant out of the way. So let's go all the way up, and you're going to see I have a constant. Let's just do all capital SSH underscore banner equals. Now I'm going to be copying this in from my previous GitHub or Honeypy project. I used ChatGPT to generate this. I do believe that there is a specific format for the banners. You can't just put in hello, but I could be wrong on that. But basically what an SSH banner is doing is when an incoming connection or client is attempting to connect over the SSH protocol, the SSH banner maybe sends some valuable information such as the version, what it's running, and any other type of metadata about the SSH server. Now you can see I've also defined a new variable called host key, and I'm calling it server.key. The server.key is going to be a private file. Remember, this is going to be a public-private key pair that we're generating. The server.key is going to be the private key or the private part of that component. And this is something that you want to guard closely. You don't want to upload this to GitHub or any sort of file drive. This is something that you want to keep secret or local. Okay, so from what we have here, we will go ahead and generate the public-private key pair using SSH keygen. So SSH keygen is a tool that allows us to quickly get up and running with a public-private key certificate. Let's proceed to generate the public-private key pair using RSA and the SSH keygen command line tool. So using SSH-keygen followed by the type, the algorithm type. Specifically, I'm going to be using -t RSA. How big do we want this to be? 2048. And the file, and we're going to call this server.key. So this is going to generate that public-private key pair, and I'm not going to enter a passphrase. You are welcome to. What you're going to see now is 2 files, server.key and serverkey.pub. So the public file can be shared wherever. It's meant to be public, denoted by the name.public. The server.key is something that is supposed to be closely guarded, like I've said. And again, what this is doing is providing a sense of identity for the server. So let's go back to our SSH honeypy and continue on with handling this connection. So the next thing I need to do is actually create a channel. So let's go and do transport.accept 100. So what this is doing is this line waits for the client to open a channel. whether that's an interactive shell, command line execution, or a system request. And the 100 parameter provides 100 milliseconds for the client to request the channel. If the channel opens successfully, then it's going to return a bidirectional tunnel for communications. Now, what we want to do is, if that client does not establish that channel connection, then we needed to handle that somehow gracefully. So let's do if channel is none, then we're going to print no channel was opened to the screen. So the next step is to proceed to send another SSH banner. This banner is going to be actually printed to the screen when you attempt to SSH into this honeypot file or server instance. And so again, I'm going to be copying what I had from my previous iteration of this project, which is called standard banner. So standard banner. And I provided just a simple little message of the day, or just a little message, which is the following. Welcome to Ubuntu 20.04, and this can be anything. This can be, hello world, dee-boo-da, it does not matter. This can just be whatever you want it to be. This is a welcome message that will be displayed when a new session has been established. Okay, so we have everything up and running. The next thing that we need to do is actually send the banner, and then we can send an instance of our emulated shell, which will allow us to, basically start capturing the commands. So first, let's go and send this. So we'll do channel.send the standard banner, and then if I can do syntax correctly, we will do the emulated shell. And we'll pass in the client, the channel object, not the client, and then the client IP equals client IP. Okay, and moving on to our accept block, if we encounter an error, something occurs here, what we want to do is implement proper error handling, and we can do this with the accept block. So what we're going to do is do accept exception, so any sort of exception, as error. And we will do a print of the error, followed by a printing of the screen, and just say, hey, something has happened, exception, or we could do error. Does not really matter what, but this will capture what's gone wrong with if this block has not effectively executed. And then we have a finally block. So what we want to do is, after it's gone through this logic, whether it's attempted to actually get successful or not, we want to close the client connection regardless. And so we actually are going to add in a nested try except block here for, once again, proper error handling. And so what we can do is do a try transport.close accept exception as error, and we'll do, once again, just something very similar to this. And now, in a real world production environment, you're going to want to probably provide more verbose information than just printing the error. But for some small script like this is be fine for the time being. And now I think we're done, besides closing the connection. So we're going to client.close, and we'll do that outside of the try except block within the finally block. Okay, so we are successfully starting to handle our client session and channel. What we need to do now is create a way for our server to listen on an IP address and bind to a specific port so that it can handle and then send that, whatever that it is, to, no. So the next thing I need to do is, we have a client handle, but how do we actually get all of this information from what we got here in the client handle to an IP address and port? What we're going to be using is sockets. So sockets, what it's going to do is it's going to listen on a specific IP address and port. Once that socket has been opened, a client is attempting to connect, then we can pass in the client handle, which will send over that information, such as starting up the transport object, which is the SSH session, handling that channel, making sure that we're adding in the host key and starting the SSH server. So what we're going to do is go down to provision SSH-based honeypot and do a define honeypot. This is going to be the main function that we're actually going to be interfacing from. So when you want to deploy the SSH honeypot, we're going to call the instance of this function. We are going to be adding a few parameters here. So we're going to start out with the address, which is going to be that IP address. We're going to need a port. We're going to be a username and a password, and that is it. Okay, so leveraging the sockets library, which is a standard library in Python, we can start handling or listening to a specific IP address and port. Let's go up to our libraries here and just do import socket. Okay. So going down to the honeypot, the first thing that I need to do is basically set up a new sockets object. We're going to call this socks, and let's use the socket library. And the method or the method we're using is socket, and we're setting a particular settings. Specifically, we're using the socket.af.inet. This is defining that it's going to be IPv4 addresses that we're going to be listening for. Next is the socket.sock_stream. This establishes that we are going to be listening using the TCP port. So it's a connection port, and it's stateful. So we want to make sure we have those settings. You have to have those settings set up when you're establishing a new socket or having a new socket object listen on a particular IP address. Next is we're going to use the socks object here. We're going to do a set sock op method. Here we can claim a few other settings. Particularly, we're going to specify that the socket.sol_socket, and we're also going to do socket.so reuse address. So what this means is you can reuse address even if it's come in before. And we're going to do this as one. And one basically enables these options, these two options here. Now what we can do is do a socks.bind. And we're going to bind to an address and port. These will be passed in through our parameters as arguments when we call the honeypot function class here. Okay, next thing is to establish how many connections we can handle. I'm going to be setting a hard limit of 100. That means 100 connections can come in, and sockets can handle that, but anything above we will have to wait or may be refused. And so now what we can do is do a little, okay, so let's make sure that we're parenting some of this information out to the console so that the user knows what's going on. So let's do a print followed by F, and we're going to do an SSH server is listening on port, and that formatted string denoted by F port. So hey, we're saying it's listening on a specific port. Now what we need to do is build out logic that is going to listen for this socket on a particular IP address and port, and it's going to accept a new connection, and then it's going to hand that connection off to the client handle, which then the SSH session, as well as the other transport method, will be able to basically be handled. So once again, we're going to be using a while true statement here. So we'll do while true and do try, pass, accept, exception as error, and prints the error. If we can do it right. Okay. So in the try block, what we first need to do is gather or collect the client IP address and port. So we're going to do a client ADDR equals socks.accept. So we're accepting on a client and address, and that can be anything. Next thing, what we're going to do is we're actually going to be implementing some threading in a moment here. Okay, so now that we are accepting on any client and address, what we need to do is start a new thread. The reason why we would implement threading is because we want to handle concurrent connections. We want to make sure that our server isn't just locked into one session at a time. And threading module, which is another Python standard library, can help us out with this. So what we can do is go all the way up to our imports, and we're going to just do import threading. Going down to our try block here, we're going to implement 2 lines of code. The first one is a new thread, and what we're going to say is, hey, let's do the threading thread. We're going to start a new thread, and the target is going to be the client handle, and the client handle takes in specific arguments. So we do args equals, and then this is where we have that client ADDR username and password. And then we can start up this new thread once we have collected that. So do SSH honeythread.start, open close parentheses. Oops, I did a triple S. Okay. And now that is good to go on that end. Okay, so at this point, we are almost finished with the SSH honeypot, believe it or not. We have an emulated shell. I was doing a bit of code review here, and I realized that there was a few things that I needed to add. So the first thing I need to do is up in my initial function, because we are adding a threading capability, what we need to do is add in a self.event. And we need to ensure that the threading.event is being used here to calculate or create a new event. And the second thing that I realized was we need to, instead of hard coding a username password like we did to just start out with initializing something, we're actually going to take in a custom username and password if we want to. Now, this is going to be a little bit different than what we have here. So the logic that I had created or thought of was if an explicit username or password was defined, that would be the only username password used, of course. Anything else would be rejected. But if a username and password were not specified, because we are declaring them as none, that means that they don't have to be specified because the default value is none, then anything would be returned as successful in that case. So we're going to change the logic here. What we're going to do is do if self input username, this block stays the same. And we're going to do if username equals, instead of a hard-coded string, we're going to do self.input username. And password equals, of course, the self.input password. Then we will return the authentication successful. And basically it will say else return authentication failed. Now, outside of this statement here, what we want to do is add in logic that says, hey, if these aren't specified, then go ahead and go through the else block, and we'll return a perimiko dot auth underscore successful. So if no username or password is defined, then that is good. So let's proceed to go down to the bottom of our code, and let's provision or call the function honeypot. Like I said, this is going to be the file that we're interfacing from. So let's do honeypot followed by an address. Now, because we're using our local environment, let's use the local address or local host. Port has to be above 2000 for the time being. If you have your computer listening on SSH, it's just better just to use a higher port while we're testing. So do 2223. Username can be anything. I'm just going to be username and password. Control S to save. All right, so all this code is saved, and if we do a clear of screen, we do. Some other outstanding items that I also missed here was the passing of the client connection into the Perimiko transport object. So make sure that we actually pass the client parameter into the Perimiko transport object. And I also realized that the format of the server.key needs to be in the Perimiko RSA key. Specifically, this is where it is able to find or locate the server key. So what we're going to do is comment out here and paste in something similar to this. Host key equals Perimiko RSA key file name server.key to locate the server. The final thing I also realized was that the channel.send was intended this way. So under the emulated shell function, this needs to be under the if char statement, not nested right with it. So it needs to be nested inside it, basically. I missed that. So what you can see is that programming is fun because you always have syntax errors. So now that this is good, if I go ahead and open up a terminal session here and supply Python 3 followed by SSH honeypot.py, and I hit enter, oh, that's important that I use Perimiko. Now if I proceed to click play here and make sure and ensure that that Perimiko library is installed, you're going to see that SSH Server is listening on port 2223. We have port 2223 open, and if we go to my terminal here and I do SSH-P 2223 username at 127.0.0.1, we need to explicitly define the port because it's the non-default 22. Hit enter. And the password is password in this case. If I can do it. Here you can see that we have generated our emulated shell. We can do ls, print working directory, who am I, and then we can do exit. So that is the basic course right here. That's great. So now what we need to do is actually get our file to log some of these commands. And to do that, what I'm going to be using is the loggers that we created. So going back to the code here, we're going to start out with the authentication of the password. So if we go down to where we are supplying the username and password, so I want to capture these in the username and password supplied by the bots in a new log file. So we're going to use the funnel underscore logger followed by info. This is how we log. And basically we're going to create a small little log file. We're going to say client self dot client underscore IP attempted connection with, and then we can do plus format username of username and comma plus password of password. Make sure to format our string. Okay, so now we have it where we can have the username and password being logged. We also maybe want to add this to the creds logger for context. So do the creds logger.info. Again, we'll do the self.client IP, the username, and the password. The other area we would like to log is these commands. So as the user or the hacker, bot, whatever, attempts to enter the emulated shell commands, we want to log them. And we can do this by, once again, using that commands or creds logger under each of these if or elif statements. So starting with the print working directory, we're going to copy and paste this. We are doing a little bit of code reuse here. I don't know if this is the prettiest way to do it. Okay, funnel. Do a creds logger. .info f command .srp plus executed by plus f client IP. Okay, so we're basically adding this to our creds logger, which will populate this in the cmd audits.log. So what I'm going to do is take this here and simply copy and paste this into each of the below statements. We also want to gather that command that is being used. And with that being said, I think that the SSH honeypot is good. So do a Control S to save, clear our screen, do Python 3 SSH honeypy. I keep forgetting I'm in my virtual environment, so I'm just gonna hit play. We're gonna go to the server here, do SSH-p, and then we're going to do a password. Hi, who am I? Cat jumpbox.conf. Exit. And now if we go to, let's see, the cmd audits, we're going to see that username, IP address, and password. And then we're also going to see what was executed. Hi, who am I? Cat. And in the audits log, we can see that the client attempted with username, password. The final thing I'm going to do before we switch over to argparse to parse these arguments is let's proceed to just add in, switching over our function call to username none, password none. Now we can enter any sort of username password pair and it will log us in, quote unquote, to the emulated shell. So you can do exit, we can get out of there. And as you can see, if we go over to our cmd audits log, you're going to see that I have username hi. So perfect. We have got the SSH honeypot up and running. That is 1/3 of the way there for this project. The next thing I'm going to do is use the argparse library to parse the arguments so that we can pass in the username and password as well as the IP address and port, making it a little bit more easier and dynamic for the user who provisions this honeypot script. Leveraging the argparse library, we're going to be able to parse command line flags or options and specify the username, password, IP address, and port. Argparse is relatively straightforward to use. It's verbose. I really like argparse, and so let's get up and running with a new Python file, which is going to be called honeypy. Going over to my VS Code here, I've created honeypy.py file under the same directory or tree as all of my other files. I have two comments, libraries, and parse arguments, and what we're going to be doing is importing the argparse library as well as importing the SSH honeypy file, and you'll see why in a moment. So first, let's start by downloading the argparse library by doing a pip install argparse. Oops, that is not how you do it. Okay, next let's proceed to download, or rather import, the argparse library. And then we're going to import the SSH honeypy file as well. So do SSH honey.py or SSH honeypy, and we're good. So the argparse library starts out by creating an instance of the argparse object. Once you do that, you can supply any number of arguments followed by whatever command line flag you want to use if it hasn't been designated. So the reason why we are using honeypy.py here is this is going to be the main file that we'll interface through. So if we go ahead and proceed to do an if underscore name equals underscore main. So the standard if name equals main construct allows us to say, hey, if we're executing from this file, proceed to do the following. And this is the main interface file, so this is what we want to use. So let's go ahead and create that new parser object or instance, and we're going to be calling it parser. And using the arg parse library, we're going to be using the argument parser method. And that will create a new instance of argparse. From here, we can add arguments using the add argument method. So let's just do a parser dot add argument. And here we can supply our options. So like I said, it's going to be IP address, port, username, password. So we're going to have 4 options. Let's start out with the IP address. So let's proceed with -A for address. And longhand is going to be -- address. Here we can specify the type. So what type of parameter or argument will be inputted into this. And this is going to be a string. We're accepting a string argument. So let's proceed to do type equals str for string. And we can make arguments optional or required. This is a required element. We have to listen an IP address and port. So let's do required equals true. Next is adding the next parser, and that is going to be the port. So just do a -p and do -- type equals int. So we're accepting an int for the port type, and required again is going to equal true. Next is that username. So we're going to do parser.add arguments. And we'll do -u for user, -- username for longhand. Now this doesn't necessarily have to be required, but if it is declared, we're going to use the type of string. And let's do this again for the password. Now because we're using -p for port, I'm going to use -pw to specify password. .pw and -- type is also going to be of string. Okay, so we have our arguments coming together. The next thing we need to do is actually add 2 more arguments, one for the SSH-based honeypot and one for the HTTP. What this will do is allow us to provision multiple instances of this Python script, and we can have several honeypots running if we wanted to, listening on different ports within the same IP address. So what we're going to do is add a parser.add underscore argument, and we're going to use -s to denote the -ssh honeypot, and we're going to add in something different here, a parameter as store true. So what this does here is basically says, hey, if there is this argument that has been supplied, you're just going to store it as true. You don't have to, we're not adding any sort of argument or string afterward. You know, right here we're supplying a password, username. Here it's just true or false. So we're storing this as true, and otherwise it's going to be stored as false if it's not supplied. We'll do the same for our web-based honeypot. We haven't coded the honeypot yet, but we will add in support. So the -h option is actually not going to be able to be used because -h is for -help. It's standard or part of argparse. So what we're going to use instead is the W, and we'll use something a bit different. We'll use --HTTP. We could also use web server, whatever you want to use, and do action store underscore true. these are our arguments. We're done with the arguments. Now what we need to do is combine these all together. And to do that, we use the parser.parseArgs method. So we can do args for arguments, and we're going to store this in the args. And we're going to do this. So that will basically collect all of these and store them in the args variable. Now we need to add some logic. So we have two types of honeypots, and we need to basically make it so that we have a honeypot specified and handle of what happens. So if we go ahead and do a try except, we'll pass on the except, and we're going to start with our try block. We're going to do an if args.ssh. We're going to run the SSH based honeypot. So let's just print a message and say, hey, we're running the SSH based honeypot. We'll output that to the console. Then we can call the honeypot argument here, and next we can actually proceed to use the honeypot function that we defined from our previous section. And what we're going to do is actually we have to change this. We need to change from import SSH honeypy to from SSH honeypy import star, and that basically imports all of our functions. So now we can reference the SSH honeypy here, and what we're going to do is just do honeypot. And this is where we can actually specify or designate what's happening. So we do args dot address, args dot port. Those are required. And then we'll do an args dot username and args dot password. So if the SSH honeypot is supplied, and that's, yeah. The next statement is going to be the HTTP based honeypot. So we'll do args.http, and we'll print a small message saying, hey, this is what we'll do. We'll run the HTTP based honeypot. And we will do a pass for the rest. Then for our final one, okay, so I've passed here because we haven't implemented the web-based honeypot, so I'm passing for the time being, and then else. So if neither of these have been specified, well, we can either create a default so that we could say, hey, we'll call the SSH-based honeypot, or we can print an error message. And that's what I'm going to do. I'm going to print an error message. I'm going to say, hey, you need to run a particular honeypot, whether it's you choose a particular All right, so our error message has been printed, and then the final thing what we need to do is accept. So in this case, because we're interfacing with this file, when a user enters some sort of keyboard interruption, such as Control-C, which basically exits out of the program, it's a hotkey to do that. What we want to do is maybe just print a message saying, hey, we're exiting the honeypy. So we can just say print, and we'll do this in a new line, say exiting honeypy. And that will exit the program. So this is it for the parse arguments. We can try this out real quick, actually. So let's clear our terminal screen here, and let's do a honeypy Python 3 honeypy. We're going to do an address of 127.0.0.1-p of 2223. -u, we are going to add logic so that if no username or password is defined or declared, then we'll just use none. But for now, we do need to define a username password, so we'll just use hi and password or password of hi, and we'll do --SSH because we have to define that. And it's not going to do that because I forgot to add my PW. You are going to see an error message. It's a default error message for using triple des, but you can see we're running the SSH honeypot on port 2223. Good stuff. So we are good with the argparse here. Let's do a Control-C to exit out of our terminal, clear our screen or terminal, and then let's proceed to add in that username password logic. So basically what we're going to say is if not args.username, then the username is going to be equal to none, and we'll do the same. And we'll do this f not args.password, password equals none. So let's save this file, and if we do arrows up, and instead of username password, we'll just do --SSH, and let's make sure this works here. Do a little testing. Hi. Okay, perfect. So basically, we have implemented that small logic here. All right, so now it's on to our web-based honeypot. Using Python Flask and a static HTML file, we are going to be creating a small little WordPress login page. All right, so starting with the web-based honeypot, I have created a new web honeypot.py file in the same directory tree as everything else. And I have one thing to note here. It's that WP admin HTML file. I briefly referenced that I wouldn't be actually writing this, and I didn't write this when I was developing honeypy. I simply just used ChatGPT to help me out. So that is always nice for the LLMs in terms of doing stuff like that. So in web honeypot, as you can see, we already have a few comments. Again, it's just to help me find a way of parsing through and building out the progress. Now, you may think that a web-based honeypot is going to be harder than an SSH honeypot, but it's actually easier because Python comes with extensive web server support. Specifically, we're going to be using Python Flask. So let's go ahead and move over to the Web Honeypy project, and we are going to enter a few outstanding libraries. The first one is going to be the logging library. We're going to create a new instance called the HTTP logger. This is going to log those username and password credentials from WordPress admin. Now, you're welcome to use the same log file, or you can use a different one, completely up to you. The next thing we're going to need to import is the Flask application. So we're going to do import Flask, or rather, from Flask import Flask render template request redirect you and URL for. We're going to be using just a few of these constructs here. Now, if you don't have Flask installed on your machine, you can do pip install Flask. That will collect Flask for us. Let's clear our terminal screen here. Okay, so starting out with our logging format and our logger. Our logging format is going to be a little different than the previous one. We're going to add in a small timestamp. I'm just trying to show this that there's extensive use cases with how you can format your logs with logger. This is just another way you can do it. So similar to what we've done before, we're going to do logging underscore format equals logging.formatter. And here we're going to add in a string and supply two parameters. We're going to have the ACS time, parentheses S, and then the message. And the message is going to contain the username and password pairs. Okay, that's it for the logging format. In the HTTP-based logger, we're going ahead and actually just copy what we've done before. So going all the way up to where we define logger, we're just going to create, or rather copy paste the HTTP logger. We'll do a little bit of something here. I forgot we do need to import the handlers library. So import from logging.handlers, import rotating file handler. And that will allow us to get that rotating file handler method. So I'm going to actually just keep funnel logger the same. In this particular use case, you can make it the HTTP logger if you want to. And I'm going to rename this to HTTP. And I'm going to change log type to HTTP audits.log, keeping everything else the same. Okay, so we're going to have two functions. The first one is going to serve up that static web page, which is going to accept a username and password. And it's just going to emulate a WordPress WP admin login page. And then the next one is going to be a small little function that's going to run our application for us. The reason why we have that second function, which is going to be called run app, is because then we can pass it to our honeypy file and we can run it from our argparse library or our logic here. So let's proceed first by defining both of these functions. We'll start out with the function of the web honeypot. We'll do pass, and then we'll do run web honeypot. Again, we'll pass that. Starting out with the web-based honeypot, let's add two parameters, the username and password. Input username is going to be equal to admin. Input password is going to be equal to password. So we are assigning defaults to the following parameters, and we'll get into that here in a few moments, but I just want to make sure that we have these parameters set in place. All right, so with Python Flask, it's relatively straightforward actually to provision a web server. The library does a lot of things in the background, so it's pretty nice if you're just somebody who's looking to provision a small scale web server, and Python Flask is perfect for that. So we're first going to be creating the app variable, which is going to assign Flask, and we're going to just equal it to the name. And if I can spell, it's going to be app equals Flask. We're going to declare the root of the web page. So it's going to be at app route of just a /. So basically this is just the root route, or the default root route. We're going to have a couple of nested functions within the web honeypot function. The first one is going to be index. So we'll just do define index. And we'll return a template, and that template is going to be the WP admin HTML. I forgot to mention that this WP admin HTML is also in the same directory tree structure as all of my other files, so make sure that they all are located within the same folder so that it knows where to route. And so if we do a define index return render template, and we do the wp-admin.html, that will be our first function. The second one is going to be the login function, which is actually going to collect that username and password. First, let's go ahead and add a new route to the HTML file. So let's do @app.route, and it's going to be wp-admin-login methods equals post. And this is a HTTP method that we are allowing to, hold on. All right, so we are designating the post method as the only method that it can be used for the user to interact with the web page. So now let's define the login page. And here we can actually proceed forward with the username and password. So let's do username equals request.form username, and I'll show you where we're getting these values in a moment. Password equals request.form password. And then we're going to collect the IP address. This is something I looked up in the Flask documentation, so allow us to get the IP address. Remote ADDR. Okay. Where are we getting these username password values? You may be wondering. If we go into our WP admin HTML, you're going to see that we have a label for username. The ID is username. The ID is password. That is how we're getting the username password. And we're passing basically whatever is inputted into this HTML. We're collecting that and storing that in a variable called username and password. So let's add some logic. We want to redirect the user to perhaps another web page, or it could be really anything. It could be a GIF file. It could be debooda. Basically, it's a way of redirecting it, or accepting the username and password. So if we do if username is equal to input username and password is equal to input password, we're going to do return debooda. That will be our message. Else, we can return a little error message saying invalid username or password. Please try again. Doesn't really matter what it is. It just has to be something. The final thing we're going to do is return the app. So we're serving all of this up here, and then basically once we have that done, that's it. We were able to now accept a username and password. So moving to our run web honeypot function, let's delete the pass. We're going to add in a few arguments here. We specifically have to define a port. So we're going to use the default port of 5000. So if no other port is specified, 5000 is used. We do have to pass in a default username and password that we define up above. And I'm actually just going to take these two parameters that we defined in the web honeypot function and just copy those in there. Okay, so now let's go ahead and define another variable called app, or run web honeypot app, and we're going to call this function web honeypot. And let's do input username, input password. Next, we will run the honeypot. So we'll do run web honeypot.run, and we'll supply the debug equals true, which will give us some output when we run the web honeypot. Port is equal to ports is going to be that default 5000, and we'll supply a default IP address as well. We'll listen to all IP addresses on all interfaces, and then we return the run web honeypot app. Save. Okay, so basically what we have here is enable capability of running the web honeypot. The final thing I want to do real quick is add in the HTTP logger function. So let's go ahead and do it so that when a username and password are entered in, we log it. So we'll do funnel logger is equal or .info. So funnel logger.info f clients with IP address of IP address entered / username password. Okay, so we're logging that in there and we're good. All right, let's do a control S, and let's just explicitly define or call the run honeypot within this file here. So let's do run web honeypot. Now we need to supply in a few parameters. We could do port is equal to 5000. We'll just actually use these here. Save our file, and I'm going to go up to my play button and play. Now this debug equals true will allow us to see some output that's served to the screen. This is just a nice way to say, okay, we have our honeypot, our web server running on 127.0.0.1, and if I go navigate to this using my web browser, copying that in my clipboard and going to 127.5,000, you're going to see the following. Now I am getting an error, it appears, and it perhaps could be a syntax error at my end. Okay, so I found my issue here. I realized that right now we have the WP admin in the root tree directory, as I said you should, and that was my fault. Now that we have it in our root directory here with all the other files, we are going to create a new template folder. So it's going to be a folder called template, and called templates, and then what we're going to do is add in or drag and drop the WP admin HTML and click move. All right, so from here we can go ahead and click play to reprovision our updates, and you're going to see our username and password, pass, log in. It says please try again, and if we go to our HP audit logs, we're going to see that pass has been entered, so that is good. Let's add in the functionality into ArgParse so that we can provision this honeypot. So let's go up to our library import, say from the web honeypot. We're going to import something. We're going to import everything, actually. What we're going to do is say args HTTP, and we're going to add in a small little section here that's just basically going to say, you know, if no username and password are supplied, we need to supply username and password. So let's just do something similar to this. We'll copy and paste all of this without that formatting, and we're going to say if not args username is going to be equal, I'm going to say args.username is going to be equal to admin, and args.password is going to be equal to password. And let's do a print of our statement here and say basically port args.port username so this will be a small little message that we're running, and then let's actually run the honeypot. We're going to do the run web honeypot followed by args.port, args.username, and args.password. Make sure to save there, and if we go to a web honeypot, want to make sure that's the correct thing. Run web honeypot. We're going to delete this here. I know I'm going a little quick here with the edits. Okay, so now if we click save, let's just exit out of here and we should be good to go. Now we have honeypy up and running with two different types of honeypots, collecting username, passwords, commands, and IP addresses. Hopefully this has been somewhat interesting as I fumble around with my words and with lots of filler words here. Let's deploy this out onto Hostinger and create a little systemd file to run it in the background. So let's transition over to the Hostinger console. Okay, so up on my dashboard here, as you can see, I'm using Hostinger for today's virtual private server, where we will be deploying the honeypy code and letting it sit and run. You can use the link in the description below to get 10% off Hostinger. It's not sponsored by any means. Now, in addition, you can use whatever VPS solution you want to. And now it's going to specifically require that you follow the instructions for provisioning their own VPS, whatever solution you're using. As you can see, I've already gone through the wizard. Hosting area makes it really easy to actually set up and deploy a virtual private server of whichever type you want. So I chose the latest version of Ubuntu, which is 24.04, and I have set up a password, and I am here, as you can see on the dashboard. In addition, you can see that I have a few tabs opened, the GitHub tabs here. First is the SSH honeypy. This is the official repository of the project. And so if you can notice, I have a few branches up. Now, when it comes to getting this code installed on the VPS, we are going to be using GitHub. We're going to be cloning the project, and then we can define some various variables. If you wanted to go out and do this yourself, you're going to need to create a GitHub account, and from there you can create a new GitHub repository. So we can go to the top of our screen, and you can create the repository, and you can name it whatever you want, and this will allow you to provision the repository. Now you need to make sure that you choose public so that we can clone it once we are in our VPS instance, and we are good to go there. Pulling up my terminal screen here, I have SSH'd into my VPS solution here by just typing in SSH, followed by the public IP address that hosting area provides, as you can see here. So if we go to our console, I'm assuming at this point you've provisioned a new VPS server, you have SSH access, it's publicly accessible, and that is the caveats that I have. So if you can see on my server, I have root access. You will need root access for this. So there's a couple of things that we will need to do. The first is if we want to actually run the SSH part of honeypy, we need to change the SSH port so that we have it listening on a different port, and then we can kind of quote unquote spoof port 22, because that's the default SSH port. So I have this guide up here from Phoenix Snap, which showcases how we would actually change the SSH default port. Basically, we're going to SSH into it, which I've already done, and we're going to take the command here, nano etc sshd ssh config, and this is going to allow us to change that default port. So typing that in, you're going to see, if I full screen this, that there's this block here that says port 22222. Now yours is going to be 22. I've already changed my default port here, so you can change this to whatever you want. This is the actual SSH port that you would use to log into your instance. So I recommend using something relatively easy, and it needs to be above port 1000, so it can't be 1000 or below, but anything 1000 or above is fair game. So I just use 2222. You could use 2223, whatever you want. And now if we go ahead and do Control X, there's a few other outstanding items that we need to do, and it's highlighted in this guide. I'll leave this in the link in the description below. We need to make sure to change our update the firewall rules so that we're allowing that new port, whatever port you decide. So we're going to use sudo ufw allow and then that brand new number. So we're just going to go down to the terminal, and if we just do a ufw for uncomplicated firewall, we could do allow 2222 TCP, and if we do ufw status, there's a whole bunch of rules that I've already added. I've done this before. You're probably just going to see a couple of them. You probably will maybe even just see the 2222 TCP. So this is good. The other one that we would like to allow is port 80, because we need that web honeypot to be running on port 80. So we can just do ufw allow 80 and followed by TCP. And that will allow us to make a stateful change to our IP tables firewall, allowing those ports in. All right, so if I go to my WSL desktop here, you can see that I have an SSH-P, and I'm SSHing into my new port. You may need to proceed to restart that VPS. On Hostinger, it's made easy. You can, either just restart through the terminal, or you can just do reboot VPS. That should reboot the configuration. And so if you actually go down and try, once you've rebooted, you can proceed to SSH into that new port. So we can just hit enter, and I can add my password. And if it authenticates, let's see, I didn't do it right. Oh, that's why. Should have added that. And I am into my VPS, so we are good to go there. The next thing I need to do is, based off of the desktop where we have actually developed our code, our IDE, remember the honeypot files here. What I need to do is basically take these entire contents, cc honeypy, this is my folder, my root folder, and basically just upload all of this into GitHub. And I don't need the server.key. That is our private key. Remember, don't upload that. That's supposed to be private. So there's a few ways you can do this. Of course, the easiest way is through the terminal. For the time sakes, I guess I'm just going to basically use the GitHub web UI to upload these files. And I realize that's not necessarily the most optimal way of doing it, but you have to either set up an SSH public-private key pair in order to authenticate in the terminal, or use OAuth. And I just decided that, there's a lot of specifics that you need to have. So, and you have to have Git installed. So whatever, I just decided, let's just go ahead and upload these files using the UI. So once again, I know that for the tutorial's sake, this probably isn't good, but if you are able to get a new GitHub repository up and running. Okay, so now I'm going to create a new repository on GitHub. So if we just do cc honeypy, you can do a description, but I'm just going to create the repository. And I should get up and running. So if we just do cc honeypy, with my new repository provisioned, I have this help screen here. You can see this uploading an existing file. And here is where I can actually upload those files. So I'm going to proceed to go into my Linux project here, cc honeypy, and basically upload this and everything that needs to be. So the templates, which includes our HTML file, the honeypy, SSH honeypot, web honeypot, server. I think that, yeah, that should be good. So let's just go ahead and click open. Okay, we can also get our, yeah, that should be good. Okay, so we have our 3 Python files here. In addition, we're also going to add the other file, which is the templates file with HTML. So if we go to add file, we're actually going to create a new file. And this is where we can create our little folder called templates. So do templates and then a /, and that's going to create a directory. And then from here, the easiest way is to just simply proceed to take your WP admin HTML file, do a Control-A, Control-C, Control-V, and call it a day. I realize this is very not a good way of doing this, but we'll call this WP admin admin.html, and we'll do a commit change. So now if we go to cc honeypy, you're going to see templates, honeypy, SSH honeypy, web honeypot. We're good to go. So we have this new repository that we can now clone into our VPS environment. We're going to install the library dependencies, and then we can provision this little honeypot. So going over to the code here, we can just copy this Python or little URL file, and this is going to allow us to actually go ahead and clone it in our VPS environment. So here I'm on my root shell, and if I just do a print working directory, I'm in root. So I am going to proceed to do a make directory, call it cc honeypy, cc honeypy, okay, and let's proceed to clone our Python files. So if we just do git clone, and then here we can clone our repository. Now you may not have git installed depending on your installation. You can just do a sudo apt install git, and that should allow you to install git, and then just supply the git clone and then just hit enter. And if we ls and do another cc honeypy, so we have 2 cc honeypys, you can see our files here. Okay, so the next thing we will need to do, as we have our files here, you can see honeypy, SSH honeypy, and the web honeypot. In order to run this, depending on your distribution and the default packages that come pre-packaged with the operating system, you may or may not have Python and the Python virtual environment installed. So I'm on Ubuntu, and you can just do an apt install Python 3. And I have already installed Python 3 on my distribution here. So make sure to go through, select the yes, and then you can install Python 3. And we will also need to install Python 3-venv. And that will allow us to hopefully provision virtual image or the virtual environments. So let's just clear out of here. Okay, so now that Python in the virtual environment is installed, we can provision a new virtual environment and download the subsequent packages, the libraries that we used while developing our little honeypy scripts. So what we can do first is basically create or activate a new virtual environment. And to do that, we could just do Python 3-m venv, followed by how or what we want to call venv. And I'm just going to call it .venv. Next thing we can do is provision or activate our virtual environment. So we can do source .venv bin activate. And you can see that we have this little venv here. And we can get out of this virtual environment, by just doing a deactivate. So what I'm going to do real quick is get into our little environment here, the bin activate. And all right, so using the pip tool, we can install the libraries that we need. Specifically, we need pip install perimiko, argparse, and Flask. In addition, we can install the logging library. Okay, so we are almost done. The last thing we need to do is use the SSH keygen tool to provision a new public-private key pair. So we can do that by following the instructions in our honeypy file here. So we just basically proceed to create a new key in the root directory, SSH keygen. No passphrase. All right, so we are almost done. We have those public-private key pair finished. And the last thing I realized is, as I paused this video, there was a few little things that I had missed. So specifically, if we go and do an ls, you're not going to see all these yet since you haven't ran it. But if we go into the web honeypot, you may or may not have left the definition statement down below here, this run honeypot. We need to delete this. And so if you have that definition declaration at the end of your honeypot, you're going to need to delete this. Okay, so I'm going to just delete all of this here. You may or may not have had that, depending on if you were running the test. Do Control X, Y, Enter. Go ahead and increase this. All right, so given this statement here, we are good to go. Now we can actually run our Python honeypot file. So I've typed in Python 3 honeypy -a00-p2224--- SSH, and this should be able to provision the new SSH honeypot. Once again, just a reminder, I am in the root directory of our project here that I had cloned, and if we just hit enter, you're going to see that a new honeypot is being run on 2224, and I also made sure to allow this new port. 2223 was being used as an existing process. I already have a honeypot running on 2223. As I was recording the deploy steps, I already had an instance of honeypy up and running on port 223, so I had to shut down that service and reprovision some settings. So going back to the UFW rules here, I have allowed port 2223 as a means of testing the HTTP and SSH honeypot. Now, with VPSs, there's specifically a host-based or probably a cloud-based firewall that typically are used. Hostinger provides its own firewall solution, and one of the things you need to do is ensure that port 2223 or whichever port you are going to use is enabled. So if we go to edit the firewall connection here, we can add in an any statement on port 2223, or you can just support any protocol. It's basically just opening this up to the internet and accept all ports. So from there, the port should be allowed. Next is provisioning the virtual environment. So make sure to do source.ven bin activate to ensure that we have the libraries installed. And then from there, you can actually type in the Python 3 HTTP honeypy, followed by the 00 address and whichever honeypot you want and the port. And up on the screen, once you type in that port, you're going to see the instance up and running with WordPress. And we could go ahead and do the same with the --SSH. And this will allow us to provision that SSH honeypot. And from there, we can see that we have it deployed. So apologies for some of the mishap here. I had not done my due diligence while I was recording the crash course with the deploy step. But this is it. We have an instance of honeypot up and running on a virtual private server, and yeah, that's the project. Okay, so hopefully you've enjoyed the crash course. You've learned perhaps something new. honeypy was really fun to develop, and maybe it was for you as well. Given that these videos or crash courses take a long time for me to develop, if you don't mind subscribing, but whatever you want to do. And yep, until the next time, have a good day.